everyone. Alright, it's Elizabeth again, and we're going to look at an example of how would you answer a question where they directly ask you to work out the friction. Right, so we did do the friction yesterday, remember kinetic and static friction. So let's have a look at how can they ask a question about friction. Now we've got a question here. It states a wooden cabinet of 60 kilograms rests on the back of a tip-back truck. Now the back tilts slowly, so that's the back of the truck. I'm not going to draw the truck in, okay? So it's got, and it makes a 30-degree angle. So we've got the slope there on the truck of 30 degrees, and we do have our object here on the back, which they give us as 60 kilograms. All right, the cabinet or the object does not move. Right, very interesting. The cabinet does not move. Now what we know about weight is that weight is going to try and pull that object or that cabinet down. So anything that I'm putting on a slope is going to roll down the slope or move down the slope. Why? Because weight has got a component that works parallel to that slope. Yes, it's also got a component directly 90 degrees on towards the slope. So there's two components of weight. One is pushing it down onto the slope, the 90-degree angle, and the other one parallel to the slope that's going to make it slide down. So the fact that it's not sliding down, because if it would have been frictionless, no friction on the surface, then this object would have slided down. Why? Because of weight, or Fg, gravitational force, the component that is parallel to the slope, working onto it. So immediately I'm also going to draw in with a 90-degree angle my weight component that is 90 degrees pushing it onto the slope. Okay, so that is our two components of weight. So if there would have been no friction, of course this cabinet would have slided down. Now what do they say? It is not sliding, it stands still. So something is holding that component in equilibrium. What can that be? Yes, you guessed it right. The only thing that could keep it there is there's a friction force. And because it's not moving, I'm going to talk about friction static. So I'm going to use Fs. That is working, and it has to be the same size to keep this object from not moving. So the same magnitude, working upwards in the opposite direction, I've got my friction. All right, let's continue. Now it says, calculate the magnitude of the friction force. Now, we know there is a formula that we can work out friction, and that formula would state that I can work out friction Fs max equals the coefficient, if I do have that, times the normal. But they haven't given me any coefficient. So I don't know nothing about that surface, which means this formula means nothing to me now. I can't use it. So let's think, is there another way how we can work that friction out? Yes, of course there is. If we look at these two forces working parallel to the slope, they're in equilibrium. What does it mean? It means that the net force working in that object on that slope equals 0. Yes, there's also the normal there. So I've got my weight pushing down, the normal, the surface pushing upwards onto the normal 90 degree. But those two are working in a vertical plane, while this is working parallel to the slope. And those two are in equilibrium, which means that my Fs max is equal to my weight or my Fg parallel to the slope. Now how do we work that out again? Weight is mass times gravitational force. So always in the place of that, I'm going to write mg times, now what is that angle? And now I'm going to bring that in. Now remember how I remember it. Is it now sin or cos? I'm going to remember it that because it's sliding down, it's because it sinned. So sine of my angle 30 degrees. Now that gives me the mass 60 times 9,8 sine 30 degrees. And let's work that out. So it's going to be 60 times 9,8 for the weight times sine 30 degrees to get the component parallel to the slope, and that is going to give me 294 Newton. That sounds a bit much for friction. Let me just redo that quickly. 60 times 9,8. Oh man, finger problems. Yes, it is. 294 Newton is the friction force, static, that works upwards. Alright? Now let's say calculate the coefficient of the static friction. Now we can use that formula because I do have my friction force as 294. Then asking for the coefficient, and I do have to work with my normal. So how do I get again to my normal? So can you see that my normal equals my weight perpendicular to the slope? So I'm going to just keep that there, 294. So I can quickly take this out. So I can either first work out the norm, or I'm going to immediately substitute. Let's do that. So I've got my Fs equals coefficient is normal. So my coefficient equals my Fs, which is 294, divided by my normal force. Now, in the case of my normal force, we just said my normal force equals my weight, or Fg, gravitational force, perpendicular. So it's 294 divided by, now that one again is my mg, mass time gravitational, cos theta, in this case 30 degrees. So we've got 294 divided by, let's work that one out, 294 divided by, the mass is 60 times 9,8 for the weight, times cos of the angle 30 degrees, and that gives me a coefficient, so that's going to be 60 times 9,8 cos 30 degrees, and I do give the coefficient as 0,43. Okay, so there is our coefficient, and again 3 marks. Okay, easy peasy. So let's go on to the next question. The angle of 30 degrees is now increased, so the angle becomes steeper. Let's say to 40 degrees. Now an interesting question. How is that angle going to influence my friction? Now how we can think of that is when I lift the slope of something, is it going to slide down easier or is it going to slide down more difficult? Of course, you know, easier, which means that the friction force will decrease. And how I'm going to explain that is because the normal force decrease. Why? My weight stays the same. It's still mass time gravitational force, which is a constant. But the moment I'm now going to say, in for instance, cos 40 degrees, and I work that out, then you're going to see your normal actually decrease. And because your friction is directly proportional to your normal, therefore your friction is also going to decrease. But let's say if this is the question they asked me. They asked, how will this change affect the following? The coefficient in question 3.2. So is this going to influence the coefficient? No. Why not? Because the surface between that surface of which that slope is made of and the surface of the cupboard stays the same. Therefore, the coefficient is the same. It's a constant. For that specific surface, it's a constant. It can't change. Doesn't matter what you do with the angle. So that's a catch one. Because you see how I started to think immediately, oh, they want me to work out what's the normal now because the angle increases, so my normal is going to go down, going to be lower, you know, and there I go. So I didn't read my question. So what was the question? The coefficient. Next question, the friction force. And now comes explain your answer. So yes, what did we say will happen to the friction force? It will decreases. First thing you're going to say, it's going to decrease. Second thing you're going to say is the normal is going to decrease when the angle of the slope increases. And because the normal is directly proportional to your friction, therefore your friction is going to decrease. Alright, so that is 10 marks, and that is now a typical example of how they can ask you friction. But as you will see, the further we go into the year's physics, the more the friction is going to be like a secondary question to be able to actually work out the real thing. So at this stage, we're just going to work it out straightforward. They say straightforward, work out the friction. Alright? And as we have seen, again, our force diagram. So always draw a force diagram. Great, guys. Believe in yourself. You can do this.